Hi, Mrs. Jacobs here, physics teacher at Naperville North High School, and I'm going to go over some key ideas that we learned from the Buggy Lab. Specifically about position versus time graphs, where position was on the y-axis and time was on the x-axis. For this graph, this is all about standard 1 for our constant velocity unit. Okay. Standard 1 is about analyzing position versus time graphs. So some key ideas that we learned from the Buggy Lab is that the slope of this graph has the unit of centimeters per second, and therefore it is the velocity of the car. Okay. It tells you how fast the car is moving. Like for every 1 second, the car was moving 30 centimeters. That's what 30 centimeters per second would mean. It also tells you the direction the car is moving. Okay, if it's a positive slope, it's to the right. If it's a negative slope, the car was moving to the left. Okay. And therefore, since velocity has both an amount and a direction, this is a vector quantity, not a scalar quantity. The steeper the slope, the faster the car on this kind of graph, okay, which is more intuitive than the other graph where position was on the x-axis. Even if it's steep negative, a steeper negative slope is still a faster car than a shallow positive slope. For example, negative 40 centimeters per second is faster than positive 22 centimeters per second. Because in every 1 second, this travels 40 centimeters to the left. For every 1 second, this only travels 22 centimeters to the right. That positive and negative is just the direction. And then finally, the y-intercept of this graph is the starting position of the car. Okay, it's where the car is at time 0. A good sample question would be you're given a position time graph. Let's call this 80 centimeters up here. And let's call this 5 seconds. And a good sample question would be find the velocity of the car. And a good follow-up question would be write the math model of the car. So if I'm going to find the velocity of the car from a position time graph, I have to find the slope. That's the definition of velocity. It's the slope of the position graph, position versus time graph. Now there's different ways to find slope. You can do rise over run. You can do y2 minus y1 over x2 minus x1. Okay. It's important to be careful while you're finding slope. I'm going to go ahead and do it in this format, and I'm going to write out the 2 different coordinates here. So this is 0 seconds, comma 80 centimeters is this first point. And the second point here is 5 seconds, comma 0 centimeters. Okay, notice I'm putting the units in with the coordinates. I'm saying this is the time and this is the position for that point. I'm going to consider this to be the second point. So this will be x2 and y2. I'm going to consider this to be the first point, x1 and y1. So if I'm going to do y2 minus y1, it's going to be 0 minus 80 in the numerator, centimeters, I keep the unit on top, over 5 minus 0, 5 seconds minus 0 seconds. So that's negative 80 centimeters over 5 seconds. I divide that out in my calculator, and I get negative 16 centimeters per second. That's the velocity of the car. For every 1 second, the car is going 16 centimeters in the negative direction. The next thing I'm going to do is I'm going to write the math model. The math model is going to be a linear model. This is the linear equation. The math model is going to use the words for the variables. So position and time, or my y and my x. My slope was negative 16 centimeters per second, because I already calculated that. And then my y-intercept was my starting position, 80 centimeters. Okay, and that is my math model. If I want to do it with symbols for position and time, a lot of people have been using P for position, but P is actually the symbol for pressure. So the symbol for position is actually capital X, like X marks the spot, which is a little confusing because it's actually the Y variable, but the symbol is X. It's just the symbol for position. I'm gonna go ahead and put that up here. And you're gonna see that in the homework. X equals negative 16 centimeters per second times T plus 80 centimeters. Okay, that's like the specific math model. The general math model for any position versus time graph that's linear is going to be X and T. The slope is the velocity. So we've got V for velocity. So we've got X equals V times T plus the starting position is X. Sometimes people use subscript I or subscript 0. That means like the position at time 0. So that's the symbol for starting position. And that's the format for any linear graph on a position time graph. Our last sample question is calculate the position at 37 seconds. So now I'm going to be using my math model like we did in Unit 1. We're using it as an equation. I know the time is 37 seconds. I don't know the position. I'm going to take 37 and I'm going to plug it in for T. I rewrite the negative 16 centimeters per second times 37 seconds plus 80 centimeters. Seconds here is canceled. So I'm left, this is a centimeters term and this is a centimeters term. So in my calculator, I plug in negative 16 times 37 plus 80. And the answer is negative 512 centimeters. Okay, which again, you're like, why would it be so negative? Because if you think about this graph, as time goes on, if this line continues in the same motion, I'm going to end up at a very, very negative position, which just means I'm way to the left of the reference point. Okay? Hopefully this was helpful.